Alright, good morning everyone. How was everyone's weekend? You alright?
How was your weekend?
It was lackluster. But so today we're going to talk about quiz 2. We're going to review if statements because that was the main thing that quiz 2 is about. Had a couple problems on those. We're going to take another look at that, see if we can figure out exactly what's going on. The only new content we're going to talk about today is nesting if statements. So basically you can take if statements and put them inside other if statements. Kind of interesting. And then we're going to have a short in-class assignment. So I'm just going to go through really quick, go through quiz 2. I think this is what I want. Yeah. Alright, so question 1. On this one, I just declared the variable a, assigned a10, assigned a11, and assigned a12. Now, a couple things I saw when I was grading this. A couple people outputted 10, 11, and 12, but there's only one printf statement, and there's only a 1% I, so we can only, at the very most, without looking or considering anything else, we can only output one integer. So the first time we assign a10, we assign a11, and we assign a12, and then we output the value of a. And then the value at that point should be 12. So, question 2, I actually made an error on. So everyone got 100% on this question. I marked everyone to 1 because it was my fault. Basically, with this question, I wanted to say float a equals 11.61s, and then say printf %.2f /n, comma, and then provide a. So if I would have written this question correctly, the printf would have been not bad. That's what the printf would have looked like. But I didn't write it correctly, so I gave everyone full credit for that one.
So if you put like 0.
If you put literally anything for question 2, you got it right.
If you put that in the computer,
it would probably crash. Because basically what it's looking for when you call printf and you specify %.2f, it's going to look for something here. It's going to look for something after your format string, and if it doesn't find anything after the format string, it's going to pull some random thing out of memory and it's going to crash and break something there. It's probably going to break, or it's going to output garbage, or you might get lucky and it might output nothing. You might get lucky. You never know. Alright, so for the third one here, we're dealing with some arithmetic and compound arithmetic operators. So we start out by saying a equals 10, b equals 11, and then we leave c as is. So we add 10 to a, so at this line we add 10 to a, and we're at 20. Then we go ahead and add 10 to a, and we're at 30. We subtract 1, and we're at 29. Then we take, okay, so a equals 29. At this line right here, a equals 29. And then this line, we take 29, and we add 11, and then assign it to c. So 29 plus 11, c equals 40. So then the correct output for printf should have been 29 space 40. And I'll say this, not nearly as many as on the first quiz. A couple people took, and when they said it was 29, I think, 2940, they put it like that. Remember, there is a space in between there because it's %i and space %i. So that first %i is replaced by 29, second %i is replaced by 40, and any other characters you put in the printf are just interpreted as is. So it should be 29 space 40. Question 4. So this wasn't meant, well, it was meant to be tricky, but a lot of people ended up getting it wrong. So let's say I put in 10, 11, 12. You look at that printf, you see ABC, you think 10 is going into A, 11 is going into B, and 12 is going into C, and you write something like this. But that's not correct. Can anybody tell me why that's not correct? Yeah, so in the scanf, B and C are switched. So we're going to read 10 into A, 11 into C, and 12 into B. So that means it's going to output 10, 12, 11 instead of 10, 11, 12, because we're reading 10 into A, 12 or 11 into C, and 12 into B. Question 5. So I type the following input of 10. We're checking if 10 or if A is greater than or equal to 10, or if A is equal to 10. Now, question 5 and question 6 are almost identical. Well, they should be almost identical. I just guess I changed the indentation to make it look like they're not identical. But so questions 5 and question 6 are asking almost the exact same thing. The only difference between question 5 and question 6 is the else, if. Question 5 is just if, but question 6 is else if. So recall that if we just say if, both of these conditions are going to be checked. We're going to check if A is greater than or equal to 10, or if A is equal to 10. So what this program should output is equal and then equal. Because we're checking both of those conditions, and since it's both greater than or equal to and equal to, it will output both of those lines. Question 6. So just remember that when we're saying if else, only one of those three conditions can ever execute. One of those, we can't have multiple outputs at the same time. So if A is greater than or equal to 10, then we only ever say greater than or equal. We never say equal because we already have had a condition that's true, and then we ignore all the other conditions below it. Question 7. So we read in 9, store it in A, we check if A is equal to 10, it's not. We check if A is equal to 11, it's not. So then the only other possibility is A unknown, so we output A is unknown. Question 8, I input the following, or I input 9, and then we do a bunch of operations on it. So we do 9, A equals, and then we'll say 9 plus 11 is 20. Then we'll say 20 plus 20 is 40. Then we'll say 40 minus 10 is 30. Times 10 is 300. Divided by 3 is 100. So the program should have outputted A is greater than 10. But, and a lot of you got to that point and got it right, but a significant portion of the people, or a significant portion of you, forgot to consider this printf after the else. Recall that after we start our if statement, we execute all of the conditions that are relevant, and then our program execution continues on below the if statement, so we can do continue doing operations in our program. So the exact output should have been A is greater than 10, and then it should have outputted what exactly A was, and specifically that would have been on 2 lines. So the 3 things wrong with this program. The first thing is we don't have any includes. Recall we need to include studio.h when we're doing puts, printf, scanf, or any other I/O operations that we'll learn about later. The second thing that's wrong is there's no quotation after hello world, so it should be hello. Right now it's just hello world, and then there's the parenthesis. We need a double quote to end that string. And the final thing that's wrong is there's no semicolon at the end of the line on the puts, so it should be that line has 2 errors. It should be puts hello world double quote and colon semicolon. So if you got 2 of the 3 or 1 of the 3, I gave a third or 2/3 credit for that. And then the last last question, so I input B, reads B into C, so we add 5 to B, so we go B, C, D, E, F, G. So we take B, we go 1, 2, 3, 4, 5, shoot, and recall, so we add 5 to capital B, so capital B and lowercase b are different things. So we go 1, 2, 3, 4, 5, then we subtract 1, and then we're left with F. So what you should have written was F. So I thought I set up the quiz to let you see answer feedback. Does that not work at all? Okay, I'll have to ask around and figure out exactly how to do that. I'm not. You were able to see it. How were you able to get to it? So just explain it so I can explain it up here. So. And then you can see what you got. And then it'd be an attempt here. Alright, that's good. So I'll just talk a little more. So this was it was hard in a couple ways. They're going to continue to get harder from here. Most of the quizzes are going to be reading code, so if you don't understand something, you really need to ask, or you need to get in and you need to practice what we're working on that week. If I'm talking about something on Wednesday, recall on Wednesday I talked about compound if statements. Now I didn't include that on the quiz on Friday, but I did include the material on all the other if statement stuff we did on Monday. So we should usually finish up our material that's going to be on the quiz on Friday on Monday, and you should have a few days to work on that stuff and figure out what's going on. And you really need to just even if there is an assignment, you need to get into the system. You need to write programs to understand what's going on. You just really need to take more time to just work on writing programs and again understanding what's going on. And if, for instance, the entire class period would have been filled up with questions, and we would have gotten to like 11:45, I would have just not done the quiz. If you really don't understand something, you really have to ask. And if I sense that there really is not an understanding, we can not take the quiz. There's no set in stone deadline that we need to take it. And if you don't understand something, just yell at me and tell me that I'm an idiot and that I'm not explaining it right, and we'll be fine. We'll get through it. So that's essentially quiz 2. Any questions as of right now? Definitely check and see how I graded it. If you think you deserve more points, again, yell at me, tell me I'm an idiot. But all right, so that's it for quiz 2 then. So I'm going to go on and just continue to review if statements a little bit. I know we love doing if statements, so let's see. All right, so real quick, let's just write an if statement. Check if A is greater than 10. It's clearly not. And then, so the very basic if statement. All we need is this. This is the only thing that's required of an if statement, is the single conditional check. We can say else. So if it's not greater than 10, it's less than or equal to 10. So with our else statements, recall that if this condition is true, we will execute all the lines inside these two brackets here. But if it's not, then if those conditions aren't true, we either go on to the next if statement. Okay, so if that condition's not true, then we execute any attached else statements, or we check the conditions of any else if statements. So we could also say else if a is less than 10. Not typing while we're there. So now a equals 10. So if a is greater than 10, we'll output greater than 10. If a is less than 10, we'll output less than 10. If no other conditions are true, then obviously a is equal to 10. So again, we can continue writing statements after we've written an if block. We can say printf %i 10. We can say a plus equals 10. We can continue adding things on like that. And we can take our if statements, we can run multiple if statements, we can take all these down here, and we can put them all down here. So just keep in mind that this is one big old if block. So this is kind of a diagram representation of what's happening here. So this is our program coming in at the top here. Let's say we said int x is 0, and then it'll check if x is less than 0, which it's not. It'll perform the statements inside the if statement, and if it is, or if it's false, then it won't perform the statements. So if x is 0 here, then that's false because x is, or 0 is not less than 0 is equal to 0, so we'll perform the non-negative statements. So this is an example of a single if. So if we said if a is greater than 5, then these are the statements inside that would be executed, and if it was false, it would go around the if statement and it would stop. So continue to build on bigger. This is what we're going to talk about today. So we can have one if statement, so a is less than b. We execute what's inside our if statement, but we can also have more if statements inside if statements. We'll come back to this diagram after we talk about compound if statements today. But this is essentially the main thing we were doing with. So we had one condition, then we had else if, then we have a bunch of, we can chain as many else ifs if we, no. We can chain as many else ifs as we want to. We can say, and then it'll execute whatever inside the curly brackets below the if statement. And then at the very end, this would be our this would be our, there's no else in this one. These are just all else ifs actually. And then after we finish our if statement, we continue on to the code after the block of if statements. So just going to talk really quick about nesting if statements. That's not what I wanted. That's again not what I wanted. That's what I wanted. Somehow I pasted a million versions of this in here. So we can say something like scanf %i a. So we're going to read in one integer from the user, and then we're going to say if a is greater than 10, and then we're going to have a block. Now we're not going to put anything inside that for right now. We're going to come back to it. And then we're going to say else if A is less than 10, and we'll just leave that block open too. So now, if we input a number greater than 10, it will execute whatever inside here. It doesn't necessarily have to be output. It can be any operation we want to, that we've talked about so far. And then if it's less than A, we can execute any operation here. And if for some reason A is 10, then nothing will ever be executed. So we can also, okay, so we're going to talk about nested if statements. So we can put if statements inside other if statements. So we can say if A is greater than 100, we can have our statement here, or else, which in this case, else is implicit that A is less than 100, because it is. So then we can say, we'll say it's really big if it's bigger than 100. We'll say pretty big if it is less than 100. So essentially how this reads is if A is greater than 10, then check if A is greater than 100, or print, or even if it's not, then print A is pretty big. So then we can say if A is less than negative 100, or sorry, I'm getting this mixed around. So yeah, this is, so let's say our number is negative 50. So we check if negative 50 is greater than 10. It's not. We check if negative 50 is less than 10. It is. But negative 50 is not less than negative 100. So the output would be A is pretty small. But if it's negative 200, then it's less than 10. And it's less than 100. So it is really small. So there's kind of two different ways we can approach multiple conditions being true. But remember, we can say if, else. We can say if, and then specify multiple conditions inside our if statement. This isn't meant to be accurate, but we could say or A is greater than 9, or remember, we can string statements like that. So just keep that in mind. So just if statements inside other if statements. Alright, so does that kind of make sense to everybody so far? If statements inside other if statements. Any questions about that? Alright. So then what we're going to do today is we're going to have some fun and we're going to make some pictures. So basically what I want you to do is draw a control flow diagram for the following program and submit it to Day 12 in class Dropbox. So just keep in mind this is the Dropbox on D2L and not on dev.dsunix. Is this what now? And then submit the PDF to Day 12 in class Dropbox, which you can find. One moment, Dropbox, right here. So essentially what I want you to do is draw coming in from the top, draw going out of the bottom. So the top is right here, start drawing right there, and then finish drawing right here. Nope, so this represents, we'll go real easy here. The diamond represents a check, and a square represents an output. So just for inside the squares, just write what it would output. So you could say, in one of your squares, you could say B equals C. I didn't spell it right, but and then write your blocks like that. So you come off and you say true, come off and say false, and you build another one. And then if they come back together, you put them back together like that at the end.
You're like using that. Draw that.
Yeah, what program?
Doesn't whatever you can draw it on a piece of paper, take a picture of it. You can draw it in your Fujitsu on Journal or OneNote or wherever. Or you can, I mean, there's whiteboards in the room too if you want to use those. I guess I don't have any markers, but I'll have 2 markers. This one's actually really good. Probably the best marker I've had in years. Used to see this, but it doesn't come up.
We draw a tree diagram.
Yeah.
We don't even have to do
Yeah. So wait, what would be the
This is the entire program, but we don't care about these sections. We start drawing here and finish drawing here.
Okay, and what do we put in the triangle?
So what you put in the triangles is the test you're doing. So you say A equals C, or you put basically exactly what's in here.
Oh shoot.
Thanks, bud.